So the senior maths challenge then from 2023, let's just head straight into it. So I could do this question instantly because I did my homework. And the homework before every math challenge is knowing that the year of the math challenge has a prime factorization of whatever it has. In the case of 2023, it's 7 times 17 squared. These numbers add up to 7, which means when you divide this by 7, it just cancels. You're left with 17 squared, which when rooted is 17. Good. By the way, just for people watching this for maybe next year, this could be helpful. Do your homework. What is the difference between 1/3 and that? Well, 1/3 is 1 over 3. That's 333 over 1,000. Cross multiply these, I guess, to get the and then there. Yeah, cool, good. We're all done here. Question number 3. Base of triangle increased by that, so that means the base was b. It's now 1.2b, and the height was h. It's now 0.85h. So you could use decimals. I decided that fractions might be easier here because I could cancel this one down a lot to like this. And then I could just multiply these two things, which I think ends up being, well, cancel down this one some more actually, because, you know, there's a 2 in here, there's a 2 in there, so cancel those out. And now we just get 51 over 50, which is, I think, an increase of 2%, because that's 102 over 100, which you would have got if you hadn't bothered to cancel that down. But I think that means an increase of 2% over the original thing. Always just finding ways to avoid having to do actual maths is a good idea. Yeah, good. In 2016, world record for that was that. Approximate average speed. So speed is distance over time. So distance was 5k. Time was approximately 20 minutes, which is about a third of an hour. So in kilometers per hour, it's going to be 5 divided by a third, which is the same as 5 times 3, which is 15. These circles have radius 2, 3, and 3. So that means this side is 5, 5, and 6. Now I'm going to work out the perimeter is 16, which means half the perimeter is 8. And now long-time fans of the R2D2 channel will know exactly where I'm going with this. Heron's formula looks like this. P over 2 is 8, and A, B, and C are just the three sides. So it's going to be 8 times 8 minus 5 times 8 minus 5 times 8 minus 6, which is this. And then, of course, there's 4 2's and 2 3's here. So when you root, there's going to be 2 2's and a 3 left, which make 12, and that will be our answer. Good. Question number 6 then. How many lines of 3 adjacent cells can be chosen from this grid? Blah, blah, blah. All we need to know, and actually, if you did the Girls Olympiad exam, this looked very similar. There was a very similar idea. But the numbers here don't actually matter. All that matters about these numbers is what remainder they leave when divided by 3. So I'm going to rewrite the table like this, because this leaves remainder 1, remainder 2, remainder 0 when divided by 3, and so on. It just goes 0, 1, 2, 0, 1, 2, 0, and so on. And now all I have to do is think, well, if I draw a line, if I get a 1, a 2, and a 0, that adds up to 3, which is divisible by 3, and so that's good. And you can see clearly this line works, this line works, this line works, this line works. In fact, all the verticals work. There's 2 lots for each column, which is 8 in total. All the horizontals also work because you always cover a 1, 2, and a 0. So that's going to be 16 in total, horizontal and vertical. And the diagonal, well, this is the starting one we could maybe go for. That works. This also works. This also works. This also works. So that's going to be 6 of those. Sorry, 4 of those. And then, of course, you could diagonal the other way as well, because 2, 2, and 2 works, 1, 1, 1 does, and so on. They all add up to 0. Or they all add to multiple of 3. So that's going to be 8 plus 8 plus 4 plus 4, which I believe is 24. There's probably more intelligent ways of doing this. I decided to write the sequence out. The difference between those two is 20 to 21. The difference between those two is 2020. The difference between those two is 1. What you notice is you get 2 numbers and then a 1, and they just decrease 1 by 1. I just decided that rather than thinking about this question, I would just write it all out until I got to the 25th. The 1s appear every 3, so that's going to be 3, 6, 9, 12, 15, 18, 21, 24, so the next one is what I want, which is 27. Some GCSE stuff to do here, converting these to fractions, I guess. So if you just know this is 4/9 and this is 49 over 99, then great. If you don't remember this little strategy of timesing by 100, taking this away from this to get 99 equals 49, divide. Of course, we can times this by 11 over 11, and then this makes 5 over 99. The 99's cancel, and you end up with 5 as your answer. Question 9 then. So when you're looking at this kind of thing, try and find the one that's most restrictive first. So 4th powers and 5th powers seem like the most restrictive thing. There'll be fewer of those. So they need to be 3-digit numbers. So let's list the 4th powers first. 3 to 4 is 81. That's not 3 digits. So, okay. 4 to the 4 is the same as 2 squared to the 4, which is 2 to the 8, which is 256. So that's a 3-digit number. 5 to the 4 is also a 3-digit number, 625. It's 5 times 125. And then 6 to the 4, it feels like difference here is already about 400. The difference will be bigger. So I think those are the only 2. So, okay, 3 across is either this or this. So that's good to know. 1 down is twice a 5th power. Now, the 5th powers are even more restrictive. 3 to the 5 is this. I just times this one by 3. 4 to the 5, if you times that by 5, you're going to get something over 1,000. So this is the only one that works. 2 to the 5 is, of course, 32, which is far too small. So 1 down can only be this fifth power. It's twice that, so double this for 486. And then, of course, you have that this ends in a 6. 3 across must start with a 6, which is a 625. And now 2 down must be a cube. The only way to get a cube to end in a 5 is if you do 5 cubed, or a multiple of 5 cubed, I guess, like 15 cubed. But that's going to be way too big. 5 cubed is 125, so throw that in. And then 1 across is a square. What squares go 4 something 1? Well, 21 squared is 441. So therefore, the last digit is a 4. 25. How many solutions, how many numbers are factors of this? This is a gorgeous question. Factorize out from this expression here 2 to the power 2022 to leave behind this, because of course the powers add to make these things. That's 4 plus 2 plus 1 is 7. And so this number here is just a lot of 2's times by a 7. So the only factors it will have are a 7 and anything that's made up of 2's. In this case, 7 here, and 8 is 2 cubed. It can't have a factor of 6 because it has no factor of 3. It can't have a factor of 9 for the same reason. It can't be a factor of 10 because it has no factor of 5. So therefore 7 and 8 are the two answers. When you're doing these kind of questions, question 11 here, just say that the first person is telling the truth and run through it, and then say the first person is telling a lie and run through it. And that's basically what you have to do. So if Wenlu is telling the truth, then that means Xander is lying, which means Xander is lying, which means Yasser must be telling the truth, which means Zoe is telling the truth. And if Zoe is telling the truth, she's saying Wenlu is, and we assumed that Wenlu was. So that's great. Everyone except for Xander is telling the truth, and there are 3 truthers in the group. Now, what if Wenlu is lying? If Wenlu is lying, then that means that Xander is telling the truth, which means Yasser is lying, which means Zoe must be lying, which is consistent because she's saying he's telling the truth, but we assumed he was lying. So that means there's 1 truther, which is Xander. He's the only one who's different to the others. So either you can have 1 truther or 3, and that's all there is to it. Greatest power of 7, which is a factor of that. So 50 factorial is 50 times 49 times 48 times 47. Now, which of these numbers actually have 7s in them? Well, this does, and 42 does, and 35 does, but 48 doesn't, and 47 doesn't, because they're not multiples of 7. So all we have to do is count down the line how many multiples of 7 there are, and there are clearly 7 of them, because 7 times 7 is 49. So the multiples of 7 are here that are going to give us a 7 in this final work are 49, 42, 35, 28, and so on. There's going to be 7 of them, except 49 has 2 7s in it, because it's 7 squared. So that gives you 8 7s in total, and the biggest factor, 7 to the k, that will divide this is 7 to the 8. And that will be our answer. It's essentially just 50 factorial is 7 to the 8 times a bunch of stuff that I don't care about, because if I'm trying to divide by 7 to some power, this is the only thing that will interact with it. So the max I can do is 7 to the power 8. We've got a pentagon here. Let's draw it. U is the point on ST, such that QPU is a right angle. Classic thing to know going into Senior Math Challenge is the interior angles of all your pentagons, of all your regular polygons. Pentagons are 108, which means this is 18. If they've decided this is a 90, so that's 108, that's 18. Angles in a triangle are 180, which means this is 54. And then you simply do a ratio of 18 to 54 to 108. Divide them all by 18, I think, and you get 1 to 3 to 6. Because, of course, this is times by 3, and this is doubled, so this one is the only one that really makes any sense at all. 14 then. So points this and this both lie on a circumference whose center is the origin. So the circle has got formula this. I'm just going to put D and D in, and I'm going to put this in as well. And I'm just going to solve this. I'm being pretty lazy. I put in D because minus D squares to D squared anyway, so that's fine. I expanded all of this out. Remember, this is 12 times 12 plus 12 times minus D plus minus D times 12 plus D times D. Same thing over here. And then what I can do here is I can just do this equation equals to this equation because the R squareds must match. So just put the 2 points in, and then the R squareds match. Say this is equal to this. Make it equal to 0, of course. Divide everything by 3. Factorize for a minus 6 and minus 10. And the solutions are 6 or 10, which add up to make 16. And that looks like it's done. Question 15. Bethany's class of 30 students. Twice as many play football and basketball. I hated this question. It's obviously a Venn diagram question, and I could not work out an intelligent way of doing it. So you know what I did? I just tried stuff. Because, that's, yeah, sure. So let's pretend there's no overlap and that there are maybe 16 basketball players. That means there are 8 footballers, and halve that for 4 of those, because there needs to be twice as many in this circle as this circle, which is satisfied, and then twice as many in this circle as here. But of course, when you add these up, you get 28, which is just not okay. The problem is that it's hard to try anything else other than 16, because if you halve 18 to get 9, you then can't halve that again to get the outside people. So the next one you have to jump up to is, I think, 20 here to get 20, and then 10, and then 5, but that's too big. So yeah, I just round through these. Classic math challenge trick if you're trying to just test the solutions. So these answers are just the things I put in the middle. Classic trick, work from this end backwards, because I have a feeling they know the questions that people are going to do by trial and error, and they put the correct answer at the end because they know people go this way. So I started with 0, and now I'm going to move on to 5, and 5 works out quite well. Put 15 here, that's 20 in the circle, you want 10 here, so put a 5 here to make 10 in total, 10 in total here, halve it for a 5, and these things add up to make 30. So the answer is 5. I didn't. If anyone's got a smart way of doing that, then great, good for you. Edge length of a cube is 2 root 2. These are the midpoints, which means that's root 2, and that's root 2 as well, which means this length here, if you know the 1, 1 root 2 triangle off the top of your head, just scale it up by factor root 2, and you'll get that this edge is 2, otherwise due to Pythagoras, but that edge there is 2. I can also find this edge here by doing 2 root 2 and 2 root 2 down here. Apparently I did this edge first, it's fine, whatever. Again, the 1, 2, root 5 triangle exists, I think, so therefore times everything by root 2 and you get this triangle. Otherwise just do Pythagoras. I think now I do the thing at the bottom, of course that's root 10 as well. 2 root 2, 2 root 2 is just double this triangle, so this one's 4. And I just need to work out the area of this trapezium here with this going on like this. So what I did was, I obviously need the vertical height, so okay, let's get that. Well, this length here is, of course, or this height here, because this distance across is 4 and that distance across is 2 and it's symmetrical, that means the missing two distances when you go straight down from here to here must be 1 and 1 to make 1, 2, 1 along the bottom. So that must be 1. So now I can do Pythagoras. Root 10 squared minus 1 squared is 9. Rooted is 3, so that's going to be 3. And the area of the trapezium is 2 plus 4 halved, which is 3 times by 3. And we end up with 9 as our area of the trapezium. This was an interesting question. So this number is a number with the digits from 1 to 9, no repeats. And wherever you break it up in pairs, so 1, 2, and 2, 4, and 4, 5, and so on, none of the numbers are prime. And it's asking you to make the biggest number you can with that. Now, the hint that they gave you here is that you can make a chain of 9, 8, 7. So let's start. If we're trying to make the biggest number possible, let's start with 9, 8, 7. Now, I can put a 6 after this because 76 isn't prime. I can put a 5 after that because 65 isn't prime. I can put a 4 after that because 54 isn't. I can't put a 3 after this because 43 is prime. So let's just go down to a 2. Now, I still can't put a 3 after this because 23 is prime, so let's go to a 1, and I can't put a 3 after that. So actually, this number has failed. Where can I insert the 3? Well, as we discussed, it can't go here, it can't go here, it can't go here, it can't go here, but it can go there. And since I want to make this number as big as possible, I don't want to move it any earlier because that reduces this digit here, which of course matters more. So I'm going to put it here, and because all the other digits are in order, I think that's definitely the biggest number you can do. And the 5th and 6th digits are this 3 and this 5 here, and so that would be the answer. Question 18 then. I thought this was quite a harsh question, but the exam solutions had quite a nice little way of doing it. I just said, well, pretend all these signs are just x's, and then typically I like doing this with the biggest term to be positive, so I'll just swap them over. And now I just use factor theorem. I just looked for things that made this 0, and because of these 8, 2, and 4, and 2, x as a half works quite nicely because a half cubed is an eighth, and that just turns into a 1. This just turns into 1. This does as well. This does, and so it's 1 plus 1 minus 1 minus 1, which is 0. So therefore, 2x minus 1 is therefore a factor. The other bracket must start with a 4x squared because 2x times 4x squared is this. It must end with a plus 1 because that times that is minus 1. And in the middle, we're looking for a 4x squared when we expand. So okay, 2x times something minus 4x makes plus 4x. Therefore, if we make this a plus 4x, that makes a plus 8x, and then plus 8x squared, and then a take away 4x squared gives us a plus 4x squared there, so that's good. You can also check the minus 2x's work. This also factorizes though it's 2x plus 1 all squared, and so therefore our two solutions are x equals half and x equals a minus half, which maybe you could have spotted in exactly the same way because it works in the same way this one does. Anyway, that means that sine of x is a half, or sine of x is minus half. I know between 0 and 360 that sine of x has two solutions to both those things. One here, and then the other here and here. So therefore, there are 4 solutions in total, and we're done here. The exam scheme had a really nice way of doing this, where you factorize out a 1 plus 2x from the start and the finish. It's 1 plus 2 sine x from the first 2 and the last 2, which works out quite well. Here, what I decided to do was just split the numerator into denominators a bunch of times. So this is just this, and then this over this is 1. So this is 1 plus this over this. And then I just did it again. So this is 1 plus 1 plus this over this, which is 2 plus that. One more time, this is 3 plus that. And now I can just look for values of n that make this a whole number, which I think is just easier than looking for values of n that make that 2. Clearly no positive values will work at all, because this is bigger than this, and so you just end up with a fraction. So okay, well, what if we just try 0 instead? Well, 0 makes 3 plus 3 over 3, which is 3 plus 1, which is 4. What if you try minus 1? Well, that makes positive 2 over, I think, 1. So that makes 3 plus 2 is 5. If you try n is minus 2, you get 1 over minus 1, I believe, and then 3 minus 1 is 2. And then the last one that works is n is minus 3, which makes this thing 0. 3 plus 0 is 3. And minus 4 won't work because the denominator is becoming too big again, just like it was for the positives. And so I think I can argue that these are the only ones that work. 4 plus 5 plus 2 plus 3 is, I think, 14, and we'll have our answer. Question 20 then. So one person is walking this way, and one person is walking this way. They're going at the same speed, and they arrive at the same time. Therefore, this distance and this distance are the same. So r plus p must equal q plus whatever this is. But by Pythagoras, this is r squared plus p plus q, all squared, square rooted. So therefore, r plus p is equal to q plus this. And this is just a case of rearranging this thing here. So what I'll do is I'll move the cube over to this side, and then I'll square both sides, which is awkward to do, but it is fine. This squares to r times r plus p plus minus q times minus q, and then you've got cross terms of rp, pq, and rq, and 2 of them for each one. So it all ends up being this. A lot of cancelling happens here. You get immediately down to that. You can divide everything by 2, which I don't think I ever actually did. Did I? I eventually did. Fantastic work, Mr. Drew. And then, of course, you can factorize out q from this side, and then divide, and you'll end up with your answer of C. Excellent. 21 then. This was super annoying because in the actual exam that I was trying to do in timed conditions, I didn't read this sentence. So I wasted a lot of time because I couldn't read the question. The height of this is root 3 because that's the radius of this semicircle, which is cool. It's equilateral, so this angle is 60, although I don't think I'm going to use that. I'm just going to call the length of the equilateral triangle x, which means this distance here is x minus root 3 because that distance is root 3. Notice how the semicircle doesn't get to here, so this isn't just root 3 as well. So this is x minus root 3. And then what I'm going to do is I'm just going to say sine of 60, because this is an angle of 60, is equal to this over that. Sine of 60 is root 3 over 2, of course. Cross multiply, or just cancel the root 3's immediately. Cool. Then cross multiply, and then add root 3, and you'll end up with your answer. Or no, you won't. You'll end up with x being 2 plus root 3. Thank God that wasn't one of the options, because I definitely would have selected it. So x is 2 plus root 3. They actually asked you to find q to x. So therefore, this whole thing is x plus root 3. If I just found this little bit, I could take it away. But of course, 1 squared plus root 3 squared is 2 squared, I believe. So therefore, this length is 2 plus root 3 minus 1, which is 1 plus root 3. And that would be my answer. 22 then is an interesting question. Whenever you have a graph question, first thing to do is check the origin, I guess. So when you put in x as 0, cos inverse of 0 is pi over 2, because that's when cos hits 0. And then you're doing sine of pi over 2, which is 1. So this graph goes through 0, 1. So okay, eliminate, eliminate, eliminate. We've only got C and A to choose from. Now the thing about C and A, the big difference is that A claims to go through 0, 1, and then claims to go even higher. So let's ask ourselves, can y actually be bigger than 1? So let's just put in 1.2, and we'll immediately have to take sine inverse of 1.2, which we can't do. Therefore, this graph will never go above 1. And this C, the one that drops below 1 immediately both ways, must be the only realistic answer. I hope everyone who attempted this question got a piece of paper, maybe the maths challenge itself, and folded it in half in the way that they wanted you to do, from this corner to this corner. Because if you did that, you'll see this kind of shape come out, where this corner has gone down to here. And if I call this length 1, this length is now 1, and so is this one. This side and this side correspond to this and this. If you're not following this, get a piece of paper and do this. Fold it from this corner to this corner. This will be roughly the edge that you do. It will look like this. If you call this length here x, here, that corresponds to this length. Again, if you unfold the paper, you can very easily see that this x corresponds to this, and this x corresponds to this. And by symmetry, those things are the same, even though my picture maybe doesn't look like it. What else can we tell? Well, that's a right angle. Again, that will be evident if you got a piece of paper and did this. And this length here corresponds to this length here. One more time, that is evident if you have actually folded up the piece of paper. Now we can just do 1 squared plus x squared equals this squared to find x. So I'll very quickly do that. The x squareds cancel, which is nice. And you get this is 4 over 3. So let's replace that with a 4 over 3 and that with a 4 over 3. If that whole distance is 3, as I claimed earlier, because I'm just choosing 1 to 3 as to satisfy this, that means this length here is 5 over 3. And let's tidy that up and we'll put that information all in here. Good. Now, this length here, again, if you fold the paper, corresponds to this diagonal here. So if that's 4 over 3, and this is 4 over 3, 4 over 3 plus 4 over 3 is 8 over 3. The total distance is 3, so therefore there's 1/3 missing across the diagonal here. What I want to do is find the length of the diagonal, so I can put it in here. So, okay, that's 1/3. This distance is obviously 1 because of this. Do some Pythagoras. 1/3 squared is 1/9. 1 squared is 1. 1/9 plus 1 is 10/9. Root it for roots 10 over 3. And put that there. And now, this question is about the fraction of area of this to this. The area of this is clearly 1 times 3 for 3. The area of this is a little more difficult, but it's just these three things added together, right? So the area of this triangle, because these are right angles, is 1 times 4/3 times a half. And the area of this triangle, which I'll work out here, is, because it's isosceles, I could use Heron's formula, but because it's isosceles, I'll put a length down here, and I'll just calculate this length here. I'll split this length in half to make root 10 over 6, and then I can do 5/3 squared, which is this, minus this squared, which is that, equals this h squared. That makes 90 over 36. Rooted is 3 root 10 over 6, because of course that's 9 times 10, so rooted, yeah, which is that. And the area of the pentagon is a half times 1 times 4/3, twice for here and here, and then it's a half times 10 root 3 over 3, root 10 over 3 times 3 root 10 over 6, which is this distance here. Work this all out. Of course, this is just 4/3 because you add it together. This here is the root 10's become a 10. 3/6 is a half. That makes a quarter. That makes a 12th. So it's 10 over 12. Add them together to get 16 over 12 to make 26 over 12, which simplifies to 13 over 6. And then this divided by that is going to be 13 over 18, which would be my answer. So lots of you probably, I'll say a few things before this question. The first thing I'll say is that the answer is obviously B. Like, it's just obviously B, because it's the only one with a root 3 in it. And hexagons are all about root 3s. So, circle this answer and move on after 2 seconds. You don't need to do this question. However, if you desperately want to do this question, what I recommend you do is look at the mark scheme on UKMT.org, because they have a very sensible solution to this problem that gets the answer, and it's really nice and concise, and it works really well. If you are a fan of mental illness, you will continue watching this video and see how I did this, originally speaking, which was mentally insane. So what I did was I called these lengths 1, obviously, because they asked me to. These lengths of the square x. Then what I said was the area of this original pentagon. Sorry, it's a hexagon, isn't it? Well, like I said, hexagons are all about root 3s. These side lengths are all 1, so it's just 6 equilateral triangles, and the equilateral triangle area is a half times 1 times 1 times sine 60. Sine 60 is root 3 over 2, which makes this root 3 over 4, times by 6 to make 6 root 3 over 4, which is 3 root 3 over 2. Good. Let's tuck that away up there somewhere. This area is x squared. This area here, if I call this y and this y, interior angle of a hexagon is 120. So therefore x squared equals y squared plus y squared minus 2 times y times cos 120. Cos 120 is minus a half. If you just draw the cos graph, that's evident. Minus half times this makes this a plus 1, so it makes 3y squared. Root both sides and divide by 3, or root 3, and you get this. Let's replace that there. Now I can work out the area of this triangle by doing a half AB sine 120. So I'll do that. This makes x squared over 3 over 6. Sine 120 is, I believe, root 3 over 2, because it so often is. And you get this, and that's the left triangle. And that's, of course, the area of the right triangle as well, by symmetry. So now what I need to do is work out the area of the trapezium, so hopefully people can see where I'm going with this. So the trapezium, now you can quickly work out that the height of this hexagon is root 3. I told you there were a lot of root 3s, because you can just look at this triangle, angle 120, side length 1 and 1, just do some cosine rule, and you get this as root 3 very quickly. So okay, that means that this little height here is root 3 minus x, which is the height of the square, divided by 2. So now the area of the trapezium is a plus b divided by 2 times h. So that's going to be 1 plus x times a half times this. I'll expand all that out, and we'll get this, and that's the area of each trapezium. So now I think I know that the area of the pentagon, which is this, is equal to this, plus this, plus this, plus this, plus another copy of that. So I think I can write down this. I've just doubled this one, because of course there are 2 copies of it, and I've doubled this one, because there are 2 copies of it. Times everything by 6. I'm going to group up all of the x squareds, the x terms, and I'm going to make sure it equals 0. And then I'm just going to divide everything by 3. And all I need to do now is solve this equation for x, because x is the side length of the square. That's what I'm being asked to do. Just solve this equation for x. How hard can that be? I'm obviously going to use quadratic formula, which looks like this. That's just minus b, just flip it over, b squared, for a and c, and then 2a on the bottom. Now this squares out to be root 3 times root 3 is 3, minus 2 root 3 plus 1 at the end. This is going to make a plus 8 root 3, and then just times 8 root 3 by this, which makes 8 root 3 at the start. And then 8 root 3 times this, well, root 3 times root 3 is 3, cancels with the 3, and just get left with 8. Cool. Now, this all simplifies to this. Where am I going with this? Well, this thing here is really nice. Just so happens that it's really, really nice. Why is it really nice? Because I learnt in primary school that 12 is 9 plus 3. And that's really helpful, because that means that this factorizes to 3 plus root 3 all squared. Because, of course, that makes a 9 plus a 3 at the end, plus 2 lots of 3 root 3. And that's great, because if that thing is underneath the square root, then that just cancels with the square, and I'll just end up with this plus minus this. So I'll do that. Of course, I'm looking for a length of a side here. So I'm going to be using the plus, because otherwise I end up with a minus number, so that's not fun. So it's going to be 1 plus 3, which is 4, and then minus root 3 plus root 3, which goes away, and we just end up with 4 over that. Cancel the 4 and the 2, times everything by 3, and then our final job, obviously the answer is this, like I said right at the start, but just for completion, let's rationalize this denominator. We're going to end up with this, divide by 6, and we end up with this as the answer. Totally just a completely legit and expected way of doing that question, I think, which is good. I loved this question. This was great. It's nice because the obvious thing to do is the thing to do. We have to factorize this. So let's factorize it. So let's take out x, y squared, because that's the stuff in common. And now this doesn't obviously factorize. In fact, I didn't spot the factorization at all. So I did, just in vague hopes, because I have done this kind of thing before. Spoiler alert, doing lots of maths questions helps you with future maths questions. I completed the square on the x's and completed the squares on the y separately. So there's me completing the square on the x's. I actually factorized out with minus first, just to make completing the square on the y easier. But when you do that, this minus 4 and this minus minus a quarter cancel, and you end up with this. But this is a difference of 2 squares. So therefore, to factorize this, it's this minus this times this plus this. And of course, this minus this is just x minus y, because the halves cancel, and this is just x plus y minus 1. And so that's our factorization. Now, you could have spotted that, like, if you have a function like this, and you put in x as 5, and that makes it 0, that means x minus 5 is a factor. Now, if you have a function like this, and you put in x as y, and that makes 0, then that means x minus y is a factor. And if you replace x with y here, y squared minus y squared plus y is 0. So that means x minus y is a factor. And then you could have figured out the other bit, I guess, yourself. Good. So now we've reduced the question to finding when this is true and this is true. Now, the thing is, we've got 3 things multiplying here to be bigger or equal to 0, which means that either all 3 of them are positive, or 0, or 2 of them are negative and 1 of them is positive. Those are the 2 cases. Now, if x and y are both bigger than 0, that has to be positive. However, if x is less than y, that means that this is negative. And if we've got 1 negative out of the 3, that means the other one is negative too. So actually, all we really need is for this, because this condition matches this condition. That means we just need this condition to be negative, which is this. And now all we have, again, because this is assumed to be true, because in a graph, we're just going to be looking at this section. And because this matches with this, all we need to do is compare these 2 statements here. The line y equals x is there. We need to be above it. So we're in this area. We're in this quadrant because of this rule here, or this kind of rule here, both bigger than 0. So we're in this triangle here. But this is a gradient minus 1 winds up with 1. So it looks like this. So, and we need to be below that. So we're in this triangle here. Good. We can work out areas of triangles. We're good to go. This coordinate is 1. We can look for the intersection of these 2 lines. This is the line y equals x, and this is minus x plus 1, which is just set x equal to minus x plus 1. And you get x as a half. So therefore, this coordinate here is a half comma a half, because it's on the line y equals x, which means this distance is a half. This distance is 1. The area of the triangle is half times 1 times a half, which is a quarter. Thank you for watching. I hope you enjoyed.